Hello guys, girls, here for my second stream in this series. We will review okay, it's back. High 20 pixels. We will review Codeforces Round 636. I'm sorry, there is some problem with video for some reason. I wonder what's up. Very weird. What if I will keep it like this? Okay, let's keep it like this. Anyway, let's start reviewing the contest. There were, I think, 7 problems this time around. In problem A, we had 3 hidden numbers, A, B, and C. And what we knew numbers that are maximum of A and B, maximum of A and C, and maximum of B and C. And we need to come up with any triple of numbers A, B, C that would conform these conditions. We need to notice that obviously there is one maximal number of A, B, and C, and it will occur 2 times, at least 2 times, amongst X, Y, and Z, which is the numbers given to us. And third number occurring should be less than or equal to that number. I missed very nice part of the statement that we can output A, B, and C in any order, so I had to do some additional work that was not required actually, but well, whatever. So I spent a bit more time than actually required on this problem. And if you have any questions, you can ask them, because there will be some typing for foreseeable future. Oh, also this time around, I hope we will have a queue of the actual submissions on the contest on the screen. We will start from the start of the contest because I forgot to run it for first like 5 minutes, but it should appear in a couple of minutes. So some copy pasting here. Hi. It's actually it's not correct. So you should. Oh, if sorted, yes, but otherwise it's yes. I missed the part about that you can output in any order. Absolutely. And the solution is not entirely correct. I forgot to have. Oh, okay, we have a queue now. Forgot to put more oracle and put more instead. Yes, Lydia, I do read problems in Russian on Codeforces. Because otherwise I would miss Russian blocks, unfortunately. And keep switching back and forth is... I always would forget to switch. So that's the reason. Note that for submission I'm actually using command line tools for Codeforces. So it helps save some time. And we've got accepted here. Meanwhile, can open all the other problems, and I think about the times that I opened problem B. Uh, uh, I had to go to the door to open it to the courier, but anyway, problem B is quite easy one. You have a permutation, you merge it with a copy of itself, so that relative order of elements in both copies will remain the same. And then you need to output original permutation. Well, you can just output elements in the order they first came in the merged permutation, because for obvious reasons, if the next first occurrence of any element is some I, it has to be next in the permutation. Otherwise, we couldn't get this from merging two permutations. So we'll wait until I get my food. I guess it took a minute or so. And then we'll type this very fast. Well, sorry, unfortunately, Twitch do not always allow Meta affiliates to use different to allow to select different resolutions. So it's up to Twitch. So yes, I'm back and I'm typing the solution, and it will be pretty quick. Just have set not we could use like array of bulls, but why use array of bulls if it would work with set, and it's just quicker to type this way. And here we go. Here we see that out of these problems, we are not accurate enough to not output white space after the permutations, which I don't like a lot, but we have to live with it. And we are moving to the problem C. Here, okay, so let's define a good array. A good array is an array that can be transformed into a non-descending array by the following operations. You can either take first or last element of array B and add it to the end of the array C. So basically, what this means is basically we have array B is something like this, like a mountain with two monotonic slopes. And the question of this problem is how many elements from the start of array A we need to remove to get a good array. So basically we go right to left until we are on the upslope from right to left. Then we reach the summit, and then we go we go until we can go to the downslope from right to left once again. Once again, pretty easy problem. So if you have any questions, not necessarily about problems from this contest, I'll be glad to hear them. Well, you can contact Lydia can contact what it's called competitive companion router about how he transliterates Russian task names. And yes, if we reached, we passed the whole array, not getting outside of our mountain, we should return 0. Oh, we're switching to problem D. Okay, so for some character C, we have a string of the length of n, which is some power of 2. And for some string S, we call it C good. If basically we can, if it is of length 1, it should contain of the single character C. If it's of length of some other length, we see either the first or the second half should consist of the character C, and the other half should be good C plus 1 string. So how would we solve it? We actually, for each length, and we need to basically to change some elements, the minimum number of elements in strings S to make it A good. What will we do? We will for each like character, we know the length of the strings that we may need to do this character D good. So it's halting for A good, half of that length for B good, quarter of the length for C good, and so on. And those strings will start in positions that are within this is divisible by the corresponding power of 2. So we will just go through all those powers of 2, find for each such possible position if what is the cost of transforming this string into the corresponding character good string. Do basically dynamic programming. So you can see we first determine the k if n is 2 to the power of k, its level. Then for a plus k, and for each position we put 0 in the corresponding array if corresponding character is equals to a plus k and one otherwise. And then go through the levels from the bottom to top, basically. You do not fill all the array each time, only on the first step we'll fill half the array, and the second step quarter of the array, and so on, but we will only query corresponding element afterwards, so doesn't really matter. So here we calculate what happen if you make like actually right half of array, right half of corresponding substring a plus I plus 1 good, and left part as a plus I, and for right it's we switch the sides basically. It should be not actually I by j, but there is a mistake which I will fix. I hope soon, right after I see that something wrong. So as you can see by now, even at least two contestants in the original contest have better have already solved for problems, and I'm just solving fourth. But as a spoiler, in the end, I shared first place in this contest, beating by 1 minute the third place. So rather fun. Okay, so I fix this bug, submit it, and we go to the problem E. Problem E, we have a graph where some edges are already directed, and we need to direct all the currently undirected edges so that the graph will be acyclic. So there is two cases. First case, if the graph is already cyclic with just the edges that are already directed, then unfortunately we have no answer. The answer is no. Otherwise, we do topological sorting on the oriented edges, and then orient edges that are direct edges that are not directed, basically from left to right, and that's it. It helps me a bit that I already have a library function for topological sort. Otherwise, it would take, I guess, 2 more minutes to implement that. So if you have any questions, once again, I'm ready to answer. So first we add all the edges that are selected already. For graphs with no topological order, my function returns just empty vector. So we just do this. It seems that when you capture a C-line window, you do not capture various pop-ups, which is unfortunate. I would think what to do with this for next time around. Oh, so yeah, we also need to find like reverse inverse permutation for order to know where is position of the given element. And here I have too much indirection. Yes, I need just to query pos of yi. We just swap them, yes. And here we go. This one is a little bit harder to see if you actually have correct solutions because it's not, the solution is not unique. You can guess that in the physical, like on the physical monitors displays, I have actually statements to the left of the IDE, but anyway. So the problem F is like this. You have a graph, actually a tree, and yes, Hive engines. You have a tree, and you can choose some vertex and remove exactly k leaves that are connected to this to the given vertex. And you want to do as many such operations as possible. So the question is how many operations is possible. And it appears that you can it doesn't matter the order or actually anything. When you see k leaves connected to the same vertex, you can just remove them and it wouldn't hinder you in any way. So it's a greedy problem. So the solution would be to have a queue of leaves and remove them one by one. And if you remove exactly k leaves from some vertex, you add 1 to the answer and lower its degree by k. And if its degree, this vertex degree became 1, you can just add it to the queue. And that's it. For some reason, this problem, this task was quite problematic for quite a few participants at the top of the scoreboard. So that's basically where I had caught up on time I lost due to not that efficient solutions of problem A and having to meet to get some package from the delivery right when I opened problem B. So here I'm contemplating if I want to do some kind of DFS solution, but for DFS solution you need to somehow guess the root of the to where root the tree, and it's not advisable because of that. So I have some live templates to do things like DFS, or in this case, filling graph with edges. Thank you for the follow, Elezinha. I hope I hadn't butchered pronunciation that much. So yes, here if you degree array, ITN, I guess one of the most popular types. And writing in C++, both C++ and Java, but not Kotlin. That would be capital I TN. Yes, a special case if k equals to 1, it's much easier to just output n minus 1 and not bother yourself with thinking what would happen. Actually, I think my solution would work without that clause for k equals to 1. Here we have geese in the chat. Yeah, is it you? Anyway. Hi, Liam. Didn't know you are into competitive programming. Oh, thank you for the Twitch Prime. Appreciate it. Also, R is the number of leaves currently removed from this node. That is no more than K. Like after it becomes K, we reset it back to 0. Hi, Hamchilai. So if we up to K, we put it back to 0, we decrease degree by K, and that's this vertex in case. And in this vertex, yes, in case it's degree is 1. And also update answer by 1, of course. So we have some time until problem J, I guess. If you have any questions, once again, I'm open to answer them. Not necessarily about this exact contest. Yes. Here we have it. If I remember correctly, this one worked from the first run. Yes. So problem G, it's not that hard, but it's a little bit more implementation heavy. Here we have table 2 by n, and each cell of the table contain number from 1 to n. We can change, we can exchange numbers in the same column, and we need to know if we can make it that way that each row is actually a permutation. So basically, each row should contain all the numbers from 1 to n. And in how many, we need to like do it in as many exchanges in columns as possible. So how would we do it? We actually, first we need to check if we have two instances of each number. Otherwise, answer is -1. We can't have two permutations if we don't have two instances of each number from 1 to n. Then we can think of it this way. We say that two columns are connected if they contain the same number in them. We say two numbers are connected if they form a pair of numbers in any one column. So this way we actually go, we have kind of a graph. Well, the first thing is answer is always that we can make it that way. And the cost is like for each cycle in such a graph, basically, if we took any column, we know we know all the exchanges we need to make, depending of if we will make exchange in that exact column. So basically, we have two variants for each cycle, and we just select one of them that is lower cost, and that's it. Not hard problem. Like not a hard algorithm, but a little bit to implement here. Here apparently I can't really use my decrease by 1 for two-dimensional arrays, so I have to skip it. That would bite me a little bit later. No, still can't. Anyway, there would be a couple of bugs in my initial solutions that I would fix afterwards. And still, if you have any questions, you are more than welcome to ask them. By the way, I guess I can move camera. Oh, sorry. Can move camera a little bit so that you can see my console window. Oh well, geek outs. I think it just come with experience. Like if you solve a lot of similar problems, you kind of start to get it quickly. Actually, interestingly, in the original contest, like how would say for people in the actual third division, there is already one contestant who solved problem G, but still no one solved problem F there, which for me seems a bit weird. But then, yes, we actually need to output actual positions where we do the switch. Thank you for your kind words, Gekots. So yeah, if you already did this cycle, we skip it. If column contains the same elements, I'm gonna skip it too, but it doesn't really matter. I mean, once again, I sometimes write code that is not really needed, but helps with the peace of mind. I would change this one back because I think I actually prefer to operate with columns and not numbers. Yeah. This is also a small mistake. Uh, I put indices in the wrong order because I have two by n table and not n by 2 table. I guess the fact that I use left and right instead of up and down kinda why I made this mistake. Some random characters. Yes. Here I shadowed repos, which will also bite me a bit. Actually, I do not need to do this, but I will fix it eventually. Thank you for the follow, Geckos. So here is a bit of a hack. If you know that you have like two elements and you know you have one of them in some variable, to get the other one, you can just add them together and then subtract the known one. Thanks for the follow, Grim Reaper. So yes, I think I first used this trick in 2006 or 2005, something like that. Yes, here we finally realize that pos is actually an array. Here we also have a small bug. Here it should be pp and not l. But I think once again we will fix it eventually. And here should be start not equals to pp. Thanks for the follow, Harshil 270. Yeah, the first run wouldn't be good at all. I have breakpoints on like out of bounds errors in my setup and line, so that's why you see that I run and it's instantly go to stop at some position. So you can see here L is equals to 4, which is not really good. Problem with debugger is sometimes you get this um, kind of exceptions because of some watches you have in debugger, so kind of recursive exceptions. I think. Yes. I noticed that I forgot to actually update the A, change like decrease A table by 1, so I do it here. Now I need to fix some transpositions of indices of indexing of this table. Yeah, like this. Here, then the main cycle. Yeah. Interesting. I wonder if I can like create um, kind of like action to change this elements order. But anyway, I think that's it about. And here, actually, I ran this program, and then the second delivery came. So I had to leave for 1 more minute. Here you see that it says wrong answer, but actually it's correct. Not yet fully correct. We still have right pushback I+1, which is a bug because we do this in Go as well. So yes. We need to remove that string, and then it will be correct answer, but not the same one as the reference solution, so I would need time to check. Yeah. And this is the correct solution now. Well, progress from any level to any high level, only thing I know to do is practice. Okay, you can actually now with all these educational resources out there, they are mostly like good for your progress if like they tell about something that you don't know. Yes, that was the end of contest for me. But mainly it's a practice. You participate in the contest, you try to solve it. Uh, if after the contest you spend quite a few time on the problem and still doesn't solve, you read the editorial and then try to implement the problem, the solution provided, and well, that's about it. You practice a lot. I think in my third or fourth year in the university, I practiced like 20 hours a week or even more. And then after you reach some level, you can usually sustain it with not that much of like practice. But to get there, you need a lot of practice. But anyway, the new educational part of Codeforces should be really good for you. I think it contains many materials from Pavel Mavrin. If I recall correctly, Pavel Mavrin also streams sometimes here. I mean on Twitch. I highly recommend him. World champion, great guy, and great educator. Anyway, here we have like the end of our stream. After all, Geothermal will catch up with us, solving the last problem on the 50th minute and getting exactly the same time as we get here. Yes. Let me check what's Pavel's channel ID. So yes, I'll put it in the chat. So, any more questions? If not, it's it for today. I hope I will bring you some contest next week as well. Maybe even two. if time will allow it. But otherwise, see you around, and thank you for watching. Let's see if there is anyone who's streaming. Thanks for the follow. Let's see if anyone who is streaming some programming. Well, I don't see any particularly familiar names. Oh, okay. Let's transfer you to Grave Gravekeeper. I hope you like Korean, but at least he do something related to Codeforces. Bye bye.